Graphing systems of linear inequalities. So like a system of equations is a set of one or more or set of two or more equations where you find the solution is where they intersect. A system of inequalities is two or more inequalities, and the solution will be the region that is shaded by all of the inequalities. So here we have 3x plus 5y is less than or equal to 15, and 2x plus y is greater than 5. And we're gonna graph these two inequalities. Now there's two ways you can graph these. You can go by intercepts, or you can convert to slope-intercept form. So I'm gonna do the first one by converting to slope-intercept form. Because remember, the first thing we have to do is just graph the line, 3x plus 5y equals 15. So that's 5y is less than or equal to 15. So we would subtract 3x. So then 5y less than or equal to, I like keeping my x in front, but just remember 15 minus 3x is the same as negative 3x plus 15. And then divide everything by 5. And we get y less than or equal to negative 3/5 x plus 15. Hope you wrote all that down because I'm going to erase it. But now's your chance to pause, right? So now we know this is the first equation. We can, in fact, erase the first equation. We know we have it in slope-intercept form now. There's our new one, right? So we have a y-intercept of positive 5 and a slope of negative 3/5. My intercept is positive 5, my slope is negative 3/5, so I'm going to go down 3 and to the right 5. Keep in mind, when you're graphing these, if you go down 3, right 5, you get the same as if you go up 3, 2, 3, left 5, 1, 2, 3, 4, 5. Same idea, right? And this is, now, here's where we notice that we have a greater than or equal to, because the line underneath means greater than, less than, or equal to. Less than because the arrow is pointing left. Less than or equal to, which means we're going to have a solid line. So there's the line for the first one. And then it's less than, so we're going to shade everything below. So all of this is the shaded region. Now we can graph the other line by using the slope-intercept method. I'm going to graph this one by intercepts just to mix things up a little bit. So I'm going to find my y-intercept by setting x equal to 0. So I have 2 times 0 plus y equals 5, which just means that my y-intercept is 5. Use red for this one, so same y-intercept. And then my x-intercept, I'm going to set y equals 0, so I have 2x equals 5, which means my x-intercept is 5/2. So 5/2 is about 2.5. Well, exactly 2.5. There's my x-intercept. Now, this one we have a strictly greater than. It's greater than, but not equal to. So we are going to use a dotted line. And there is my dotted line for this one. And here's where things get a little bit tricky if you graph by intercepts. If we had converted this to slope-intercept form, we might have had to change the inequality sign. So when you graph by intercepts, what you can do is test a point to figure out which side to shade. And really, you could do this when you graph it by converting the slope-intercept as well. When I say test a point, so I'm going to ask, does 0, 0 lie in shaded region? Because when you think about it, this dotted line, and the other line as well, it divides the graph into two halves. We have the part that is shaded, right, all of that, and then we have the part that's not shaded, right? So does 0, 0 lie in the shaded region of 2x plus y greater than 5? So I just have to plug in 0 and 0. So I have 2 times 0 plus 0. Is that greater than 5? Well, is 0 greater than 5? No. So, from my dotted red line, if this is the region that includes 0, 0, for my dotted red line, I'm going to shade the part that doesn't include 0, 0, which would be everything over here. So then the solution to the system of inequalities is the part that is shaded by both inequalities. So right in here we have the red and blue overlap. It's going to work. There we go. Right in here we have the red and blue overlapping. So that section is the solution to the system of inequalities. Let's do some more. That's not what I wanted. That's what I wanted. Let's do 3x minus y strictly less than 9, 2x minus 4y greater than or equal to 12, and y less than or equal to 10. So this one it's a system of 3 inequalities. So now we're looking for the region where all 3 overlap. So I start by just graphing. So if I have 3x minus y strictly less than 9, let's graph it by intercepts. So the y-intercept of this would be 3x equals 9, which means x equals 3. And the x-intercept or that's the x-intercept already. This is the x-intercept, x equals 3. And the y-intercept is where x equals 0. So I have negative y equals 9, which means y equals negative 9. There's my y-intercept. And I've got enough information to draw this line. Now it's a strictly less than, which means I'm going to use dotted line. A blue dotted line. And I need to figure out which way to shade. The advantage to converting to slope-intercept form is if you're careful and you make sure to switch your sign when you divide by negative, then you'll know which way to shade based on what sign. Now, I'm going to do this one be the other way, where I just check a point. So does 0, 0 lie in their shaded region? And I'm just going to check. So if both x and y are 0, the question really is, because I'm plugging 0 in for both of them, 3 times 0 minus 0, is it less than 9? Is 0 less than 9? Yes, it is. So 0, 0 does lie in the shaded region of this graph. So 0, 0 is right here. So I'm going to shade everything that includes 0, 0. So which means it ends up being the top side of the line. Now we graph the next line. This one I will convert to slope-intercept form, just so you know that you can always do both methods. If you don't like this checking a point and graphing by intercepts, by all means, convert it to slope-intercept form. So if we have 2x minus 4y greater than or equal to 12, minus 2x minus 2x, then negative 4y is greater than or equal to negative 2x plus 12, divide everything by negative 4. Remember, we divided by a negative here, so our inequality sign gets reversed. So instead of greater than, we have less than or equal to. Negative 2 divided by negative 4 gives me positive 1/2 x. 12 divided by negative 4 gives me negative 3. So now I'm graphing the line y is less than or equal to 1/2 x minus 3. Switch to red, so I have y-intercept of negative 3, slope of 1/2, so up 1 over 2, up 1 over 2, and be down 1, left 2, and I'll draw my red dotted line. And since on this one I have in slope-intercept form, it's a less than or equal to. Oh, good point. That's a less than or equal to. Which means this line should not be dotted, but solid. Solid line because it's a less than or equal to, right? Which means the line itself is included in the inequality. And since we have less than, it's going to be everything below that's shaded. But I'm not done yet. No, I am going to change my original problem a little bit. Because less than 10 means I shade the whole graph. Say this is a less than or equal to negative 5. Negative 6 even. Y is less than or equal to negative 6. So I have one more line to graph. Now this one's easy. Y less than or equal to negative 6, that's just a straight horizontal line across negative 6. And it's solid because it's less than or equal to. We'll use green. So I go down to negative 6, and I draw a straight line, horizontal. And then I'm going to shade everything below because it's less than. So now I'm looking for the region that has all three inequalities. So it's got to satisfy all three. So here I can see the part that is shaded by all three is right in here. Oh, wow, I wasn't expecting that to happen. But it's right in there. This part where all three are shaded. So where you see all three colors where I'm shading now, that's the solution to the entire system. So that's going to conclude this workshop on graphing linear inequalities. The real trick is just whichever method you choose to use when you're graphing your inequalities, just make sure you're careful. And then at the end, you've got to go and make sure you find the region that is shaded by all parts of that graph, or by all of those inequalities. All right?